So I am Purnima from JSS Art, Science and Commerce College, Uti Road, Mysore, Department of Chemistry. I am here to present the atomic emission spectroscopy slides. So introduction of atomic emission spectroscopy. Atomic emission spectroscopy uses quantitative measurements of the optical emission from excited atoms to determine the analyte concentration. So this concentration is uh, by the optical emission. It means the lens is used here to determine the analyte concentration. Analyte atom is the solution aspirated into the excitation region for where they dissolvated, vaporized and atomized by the flame, discharge or plasma. So here the analyte is aspirated by the use of flame with the help of the optical lens. The high temperature atomization sources provide sufficient energy to promote the atoms into high energy levels. The atoms decay the back and lower levels of emitting light since the transition are between the distinct atomic energy levels. Uh, the emission lines in the spectra are narrow. So here the spectral lines transferred in the lens are narrow. The atomic decay to the lower level of emitting lights. The spectra of multi-elements elemental samples can be very congested and spectral separation of nearby atomic transitions require a high resolution spectrometer. So this kind of spectroscopy is done in the high level of spectrometer. So it needs a higher energy and higher detector resolutions and everything. Since all the atoms in a samples are excited simultaneously, they can be detected simultaneously. And the major advantage of AES is compared to atomic absorption spectroscopy. So here we can not determine only the one atom. We can uh, determine the many atoms at the single time. So here, this is the instrument. We can see here the instrument of atomic emission spectroscopy. Here, the we can see as the sample is introduced here, and the atomic atomization and excitation is happened here. Then the detection of the atomized excited sample is done through the lens. So we can see here the length, the wavelength selector. To the length, the wavelength is selected through the wavelength selector and the detector is here present. So this detector uh, detects the wavelength and we get the wavelength at the absorption is happened. So this is the instrument. This is the small instrument where we can see the how atomic emission spectroscopy is taken place in a simple model way. So the liquid samples are nebulized. Nebulized means the sample is happened in a spray or in a gas manner and carried out in the excitation source by the flowing gas. The gas is transferred there in the spectrometer. There it follows the solid sample can be introduced into the source by the slurry. We can make the slurry of a solid sample, then introduce into the spectrometer. The solid can also be directly vaporized and excited by a sparing spark between the electrodes or by the laser plus. We can directly do it into the spectrometer or we can do uh, before before the experimenter is here, the atomization and excitation is explained. In atomic emission spectroscopy, the sample must be converted to free atoms, usually in high temperature excitation source. So now we take the sample into the spectroscopy, and this spectroscopy and it is converted into free atoms. So in the spectrometer, the high temperature is introduced and the excitation of sources is happened. The excitation source must be dissolved, atomized, and excited the analyte atoms. A variety of atomization excitation are present, like flame, arc, spark, and plasma. Detection of spectra are often complex and frequent, comprise hundreds and even thousands of lines. Spectra for the many elements can be recorded simultaneously and multi-element analysis is possible. Therefore, requires high-resolution wavelength selectors and sensitive detectors. So here in the atomic emission spectroscopy, we the solution is very complex. Even the here comprises of 100,000 lines means here many wavelengths of radiations are passed through the analytes, uh, and the elements are detected as the different wavelengths, because here the different atoms contain different number of wavelength. So atomic emission based on plasma sources. The plasma sources are important and most widely used sources for atomic emission spectroscopy. Plasma is an electrical conducting gaseous mixture. Significant amount of cations and electrons are present here. This plasma source increases the atomization and excitation. Wide range of elements are present here. Elements that tend to form refractory compounds, that is compounds that are highly resistant to the thermal decomposition, such as oxides of boron, phosphorus, tungsten, uranium, zirconium, and niobium. In addition to plasma, sources permit the determination of non-metals such as chlorine, bromine, iodine, and sulfur. Simultaneously, multi-element analysis has happened in the atomic emission spectroscopy. Wide dynamic range of elements are present. Before the sample is you introduced into spectroscopy, in the argon plus are frequently used for the emission of analysis. Argon ions and electrons are the principal conductive species. Although the cations from the sample are also present in the small amount. Argon ions once formed in the plasma can absorb sufficient power from an external source to maintain the temperature at level where further ionization sustain the plasma ident- indefinitely. Such plasmas achieves temperature as high as 10,000 Kelvin. Their classes of plasma emission instruments can be presented including sequential, simultaneous, and multi-channel and Fourier transformers. Fourier transformer instruments have not been widely used in atomic emission spectroscopy. Sequential instruments. In this class, the of instruments, a single channel of detector is present. Here, in the sequential instrument, only one single channel detectors are used. Single channel means only one channel is present. No, not the multiple channels are present for in the detector. In the single, for each element is read using the specific wavelength for each element sequentially. Two types of sequential instruments are available: linear sequential scan instruments and slew scan instruments. In linear sequential scan instrument, where the wavelength is linearly changed with time, therefore the granting is driven by the single speed during an analysis of interest. Sleeve scan instruments, where the monochromatic is percent to provide the specific wavelengths, moving were very fast in between wavelengths while moving slowly at specific wavelengths. Therefore, two-speed motors driving the grand thus used. So here in the sleeve scan, monochromatic elements, sequential monochromatic sleeve scan spectrometer. Even with many lines, much spectrum contains no information. Rapidly scanned across blank regions, slow scanned across lines, computer controlled per pre-selected lines to scan. Sequential instrument. PMT moved behind the aperture plates or granting prism moved to focus wavelengths on the exit slit. Cheaper, slower, pre-conformated exit slits to detect up to 20 lines sleeves. Simultaneous multi-channel instrument. The simultaneous multi-channel instrument incorporates either a polychromator or a spectrograph. Polychroma- Polychromator contains a series of photomultiplier tubes for detection, but spectrographers use two-dimensional charge injecting devices or charge coupled devices as a transducers. Here the graphiting, here the polychromator contains only one series tube, but the spectrographer uses two-dimensional charge injectors. So here we can see the simultaneous multi-channel instrument. So first the lens is present, the flame is present, two position mirror is present. So where in the this is a complex instrument where here the this is the simultaneous multi-channel instrument. It's expensive and but it here uh, the emission happens faster. So here we come to the end of the atomic emission spectroscopy. Here the advantages of atomic emission spectroscopy is atomic emission spectroscopy can detect very low concentration of elements, making it suitable suitable for analyzing trace elements in various samples. It can also analyze a wide range of elements with a single excitation source. Unlike absorption spectroscopy, which requires specific sources for each element. So, in atomic emission spectroscopy, we require many elements for the detection of different atomic atoms.